report for the proposed small dam and reservoir site in Matipa area, and it's found in the Fotakuma Tobas local municipality in Limpopo, and the dam axis was found to be on the high elevation, and also the reservoir basin was found in the low-lying village, and this is the reservoir basin, and upon examining the site, I found a catchment here, and it's located there. So the climatic regime and the weather analysis, it shows that it has a rainfall from 500 to 580 millimeters, and the evaporation rate is above, it's almost 3 times the rainfall. That causes the soil to be very dry and to be strong. So the weather formula shows from this, it shows it's supposed to be more than 5, greater than 5, which is the standard penetration test, and the engineering consequences for this is mechanical disengagement dominate over chemical decomposition. The grouting condition predicts the shallow weathering zones and accessible bedrock. So the regional and the local site geology is stratigraphy, esteem limb, brevet, igneous complex, and point A materials are found to be medium green nerite and gabbronirite, which is above 150 MPa compressive strain. The point A materials also are alternating nirite, andesite bands, and alluve stream sands. So the fresh bedrock offers excellent bearing, but andesite contacts are prone to localized weathering. Problems for the geohazard is being found to have expansive clay because rain falls from there and carries the sediment down. And when the sediment down, because the area has 3 times the rainfall, it causes expansive clay. And also when rain falls, it also causes depressed sieve soil that comes from when it falls here. When it falls here, it causes this. The rainwater comes here and causes depressive soil and collapsible soil that is transported, and also may need also to be compacted. Pre-wetting needs to be compacted because it can also tamper with the structure. And also the solution cast the sinkhole risk is negligible due to the massive mafic Engineers geology. So discontinuity metrics and permeability risks of the site, the joints. So joints may allow seepage through foundation, and if not taken into consideration, may cause the foundation to overturn or sink or even destroy the structure. So the solution can be foundation grouting or cut-off change. And also fault are very dangerous and more serious because they may contain crushed weathered material chloride that can be prompt to the foundation of the dam and makes it can be collapsed or prompt to sliding or settlement. So if the side bedding plate is horizontally found, it's good for the load coming in, but if it's vertically like this, that means settlement can be prompt and settlement can happen. So especially if it's a sedimentic rock that are present. The phase field investigation design, which needs to consider must be the regulatory drilling, 6 diamond core, 2 bitumen, 2 foundation, and also 2 basins. So two and two must be carried out in order to determine the profile of the site so that engineering solution can be proposed and various materials selection can be properly taken in consideration. So try pit test also 12 mechanical test pits to lock the profile using the standard descriptors, and also in situ verification to verify if all of those speculation and all of those feasible information is true. And also the soil profiling, metal grain grading at table limits must be taken in consideration. So this testing at table limit must be taken into consideration to determine the plastic limit and the liquid limit so that we know the kind of soil we are dealing with and the kind of load we need to impose on the soil, and know the maximum limit the soil can exceed before it turns to liquid and breaks from the plastic. So the erosion test also must be taken into consideration, the pinhole and the crumb test to check for the depressive soil. In case it happens to be depressive soil, this solution can be proposed. And also rock perimeters and on axial compressive strength test also must be taken, and direction test along the plane also must be taken to determine the kind of rock that is underneath the foundation, so that we didn't want a foundation to collapse or overturn when it's been retaining the water. So safety must be considered when you are digging a hole that is 1.5 meters deep. You need to consider to ensure so that it prevents the collapsible soil from entering and collapsing on you. Occupational Health Act compliance deals with these Section 8 safety duties, and also environmental laws. You need to have a license so that you are able to channel the water to the right sources and also able to treat the water that the dam will be retaining and it doesn't cause any burden to the nearby society. So by doing this, you also know how to predict the flood line and also the aquatic biology vectors that to check all of them in case it has to be harmful to the environment and also deal with them. A feasible study must be considered site structural visible but feature high elevation slope variation and nearby resident. All these high elevation and nearby resident must also be feasibly considered, and immediate action must be taken after the drilling has been taking place. So drilling and testing has been taking place before immediate action. So any design speculation and any design assumption should not be taken in consideration except the drilling has been taking place and test. So next milestone, run a Lugan pressure test to qualify the foundation grouting requirement. Thank you.